My next comment is related to a question in which you're given an elevator which has a given velocity function, and I believe you're asked when the scale you're standing on would read the same as the scale if you were standing on a scale out in the hall. And the first part of the answer I got is when the velocity is equal to gravity. Now, there's a clear error in this statement. Now, velocity and gravity, if we assume that gravity means acceleration of gravity, this is an acceleration, this is a velocity, they can't be equal. They're different. Types of things. And they can't be compared, if any of that is legible. So that's a completely erroneous statement, but the idea, and I'm not sure the execution might have actually been correct, but that's the kind of statement that'll really get you in trouble. If you try to set the velocity equal to the acceleration of gravity, well, if you leave the units off, you could get a perfectly good solution. And given that this is done in a class where not everybody is very meticulous about checking their units, as we can see from a couple of these other questions, that's just really inviting big trouble, okay? If you try to set the velocity equal to gravity and include all the units, you will get something that doesn't make any sense. The units won't make sense. You'll get numbers that work out, but the units won't. That's a flag. You really have to do something about that. And of course, what we really want to say is when the acceleration of the elevator is equal to the acceleration, is zero, okay? The acceleration is not even equal to the acceleration of gravity. When the acceleration of the elevator is zero, then the scale is going to read the same as it would out in the hall, because the acceleration times your mass is the net force. And if the net force is zero, that's the same situation you have out in the hall, where gravity's pulling you down and the scale is pushing up with an equal and opposite force. So if the acceleration of the elevator is zero, the scale is going to read the same as it would out in the hall.